Now, is this recording? Yeah, all right. Question 6 and 7 look interesting. I just had a quick play with these questions, and you can find the answers to these by comparing the log statements, sort of equating them. So let's do those. In the first question, f of x is a log 2x plus b. F of x, a log 2x plus b, where, so they're giving us a's and b's, which we don't know, but then they tell us that f of e is 3, and f prime of e is 6 on e. Okay. So if we substitute in an e into this function, we know the answer equals 3. So therefore, a log 2e plus b equals 3. You might want to do some rearranging. So you have an a equals or a b equals. We could say a equals 3 on log 2e plus b. Or from there we could say log of 2e plus b is 3 divide a. And then get rid of that log using making it a power of e. So therefore 2e plus b has to equal e to the power of 3 on a. I'll put that to aside for 1 minute. And now let's look at the derivative. So the derivative of this function is a on whatever's in the log goes on the bottom, 2x plus b, and then we look on the inside, we have to times by 2. We know that if we substitute an e into this derivative, we get the answer 6 on e, therefore 2a on 2e plus b, and the 2e plus b's being popping up over here, equals 6 on e. We could divide both these by 2, which might help tidy them up a bit. So divide by 2, divide by 2. We need to do a bit of rearranging. We could say a times e we could just leave it as an a equals. So these questions, you know, maybe it's not exactly clear where to go. That's okay, you can do a bit of rearranging. Maybe you want an a equals here. 2e plus b on e. Maybe we want a b equals, which we could do. So let's try and do that. We've got 6e here, so we'd have ae equals 6e plus 3b. We could bring the e over there. So I'm still sort of just playing with rearranging this function. A e minus 6e equals 3b. I could say a b equals, could even factorize e, a minus 6 all divided by 3. What expression have I got for a? It doesn't look very healthy. What about B? What's a B supposed to equal? A B from here could equal e to the power of 3 on A minus a 2e. So I could say this has to be the same as this one. AE B equals, so maybe we'll try that. So I'm thinking we call this equation 1 and call this equation 2. And we'll sub 1 into 2. And we get e to the 3 on A minus 2e equals, do I want to take it back a step and say it's AE minus 6e all divided by 3. Yeah, that's looking pretty good, I think. So what we get there is these cancel out, and we have e to the power of 3 on A has to be the same as A divide 3 times e to the power of 1. So I've got 1 e to the power of something has to equal a on 3. So it's like a on 3 has to equal 1. And I can see it there in the coefficients. And I can see here in the powers, and 3 on A has to equal 1 in my powers. Now they both lead to the same solution. It follows that A has to equal 3, right? So the algebra was a bit confusing, but the key is really in here, where I can set up expressions for E and then do this comparison, or saying, well, they have to be equal. We're just equating powers and equating coefficients. Now I think there might be some slightly different ways to arrive at that answer, depending on where you go with your equations. But hopefully you get something from watching me do it. And the procedure that I'm following is, after I've substituted numbers in, I'm generally trying to look for an equation where I've got an A equals something or a B equals something. I didn't particularly want to work with the A equals because of the logs that were there. And I did the same thing here. I had an A equals, and I ended up with a B equals. Then eventually the solution did fall out when I decided to substitute something coming from the function into a different set of equations coming from the derivative, right? So that has worked out okay. I still need to work out B when I've run out of room on my page. So I've got a nice expression for B. Okay, there's one over there. Why don't we use that? So given that A was 3, we could now calculate B in equation 1 here. I'm still in orange. So B has to equal E minus 2E. So therefore B equals minus E. Right. Okay, so that was question 6. Look at 7, where the algebra might be bit heavy in this question as well. We've got f of x is ax log x plus b. This is now 7. F of x equals log, I've forgotten already, ax log something. Let's try that again. Ax log, now is it x plus b? Yep. Where f of 1 is half log 3, and presumably something in the derivative. F of derivative of 0 is half log 2. Just looking at these log statements, I'm thinking you could rewrite them. Now, this is log of square root 3. I'm not sure if that'll help or not. And this is log of square root 2. Right, so I put that power in the log if I want to. Okay, so let's substitute 1 into the function first. And we'll get a. So that x has become a 1. This x is also becoming a 1. So we get a log b plus 1. And that has to equal half log 3. Now the log's in the same base, and I'm at this point I feel like we've got the answer, to be honest. I feel that, so a, I'm suspecting that a is a half, strongly suspecting, and that b has to be 2, because we can just do this comparison of the logs. But let's check it in the derivative. So the derivative, I'm going to have to use the product rule. So f of x is u times v, where u is ax, u prime is a, v is log x plus b, and so v prime will have to be 1 on x plus b. And so therefore the derivative will be a log x plus b plus ax on x plus b. Now we're going to substitute a 0 into that, okay? And so we'll get a log b. This will all become 0. And we know what it equals. It equals half log 2. Right. And again, I'm getting the same answer coming out of here. I'm seeing that a is half and b is 2. And I don't think we need to do anything else with this question. I mean, we could start playing around with them if we like. But I don't really see any point. I think we're done. All right, we saw the same pattern we saw up here. We've got logs in the same base. We can compare them, right? Normally, what I'd be trying to do is rearrange and get an a equals from each equation and a b equals, and then I'd be trying to substitute that, the equation from the function into an equation from the derivative or vice versa. But here, I'm convinced, and I wouldn't worry about doing anything else with that question. We've solved it.